Good morning, dear students. Today we are going to explain about Unit 1 Structure and Bonding Model. In the first concept, Planck's quantum theory, dual nature of matter. Planck's quantum theory, dual nature of matter. Dual nature of matter, another name is de Broglie equation. Before going to that structure and bonding model, we revise Bohr's atomic theory. Bohr's atomic theory. According to that Bohr's atomic theory, Bohr stated absorption and emission phenomena. According to Bohr's atomic theory, absorption means whenever electrons jumps from lower energy levels to higher energy levels. Whenever electrons jumps from lower energy levels to higher energy levels which require some energy. That required energy is nothing but absorption. Emission means whenever electrons jumps from higher energy levels to lower energy levels which releases some energy. That released energy is nothing but emission. This is the Bohr's atomic theory consideration. What is absorption? What is emission? Okay, let us start our Planck's quantum theory. Before going to that Planck's quantum theory, see the general example. In this general example, we take two persons. A and B are the two persons. These two persons fighting together. A spray the water towards B in continuous manner. A used water continuous pumping of water towards B in continuous manner. But B used small stones in fighting discontinuous manner. B used a small stones in discontinuous manner. Here these two persons are enemies. Our consideration is two persons are enemies. But these two persons are not enemies. Where A is James Clerk Maxwell. A is James Clerk Maxwell. He belongs to classical physics. James Clerk Maxwell. He belongs to classical physics. B is Max Planck develops quantum theory. Okay. These A and B are the two scientists. James Clerk Maxwell. James Clerk Maxwell explained that energy emission or absorption is in continuous manner. But Max Planck confirms that emission and absorption phenomena is in discontinuous manner. See, this is the general example to explain that Planck's quantum theory. Okay, here see the Planck's quantum theory scientist. Okay, our scientist is Max Planck in the year 1901. In 1901, Max Planck initiated quantum physics by presenting his quantum theory. In 1901, Max Planck proposed that quantum theory. He was awarded Nobel Prize in Physics in 1918. Nobel Prize is the prestigious prizes for all scientists. Okay, it is a dream for all scientists. Okay, right? He was awarded Nobel Prize in Physics 1918. In Physics 1918. Okay, that is the scientist details. First we consider A and B are the two persons. In these two persons, A person use continuous pumping of water. B person use discontinuous manner of small stones. A is James Clerk Maxwell and B is the Max Planck. James Clerk Maxwell confirmed that absorption and emission phenomena is in continuous manner. Max Planck confirmed that emission and absorption process is in discontinuous manner. So in 1901, Max Planck initiated quantum physics by presenting his quantum theory. He was awarded Nobel Prize in physics in 1918. These are the scientist details of Planck's quantum theory. Okay, let us start our postulates. Which are the postulates present in Planck's quantum theory? In that postulates, the first postulate is energy is not emitted or absorbed continuously. Energy is not emitted or absorbed continuously. It is emitted or absorbed in the form of wave packets or quanta. Wave packets or quanta. Energy is not emitted or absorbed continuously. It is emitted or absorbed in the form of wave packets or quanta. Okay, in the form of wave packets or quanta, where energy packets, okay, energy packets is singular is quantum, plural is the quanta. In case of light packets there, that is the photon. Okay, this is the first postulate which are present in Planck's quantum theory. What was that? Energy is not emitted or absorbed continuously. Energy is not emitted or absorbed continuously. It is emitted or absorbed in the form of wave packets. That is, energy packets is the quanta, light packets is the photon. Okay, that is the first postulate. See the second postulate. The second postulate is the amount of energy associated with quantum of radiation. The amount of energy associated with quantum of radiation. Associated with quantum of radiation, okay, is directly proportional to frequency of radiation. Directly proportional to frequency of radiation. So, energy is directly proportional to frequency. So, we get E is proportional to nu. E is proportional to nu. Okay, there is a proportional symbol. We remove these proportional symbol using proportional constant. Okay, this theory is Planck's quantum theory. So, our proportional constant also Planck's constant. So, we get E equals to h nu. E equals to h nu. Okay, that is a Planck's quantum theory second postulate. The amount of energy associated with quantum of radiation. The amount of energy associated with quantum of radiation is directly proportional to the frequency of radiation. So, according to this statement, E is directly proportional to nu. E is directly proportional to nu. Okay, there is a proportional symbol. We remove these proportional symbol using proportional constant. This theory is Planck's quantum theory. So, we substitute proportional constant also Planck's constant. So, we get E equals to h nu, where E is energy of radiation, nu is frequency of radiation, where h is the Planck's constant. So, our Planck's constant value is in two cases. One is Joule case, another one is X case. In case of Joule case, 6.626 into 10 to the power minus 34 joules per second. 6.626 into 10 to the power minus 34 joules per second. In case of X, 6.626 into 10 to the power minus 27 x per second. That is the second postulate. See the third postulate. In that third postulate, a body can emit or absorb energy only in terms of integral multiple of a quantum of photon. A body can emit or absorb energy only in terms of integral multiple of a quantum of photon. Integral multiple of a quantum of photon. So, we get E equals to nh nu. Our formula E equals to nh nu. E equals to nh nu, where n equals to 1, 2, 3 and so on. N equals to 1, 2, 3 and so on. So, in case of, we already know from lower standard, C equals to nu lambda. C equals to nu lambda. So, nu equals to C by lambda. Nu equals to C by lambda. Substitute these new value in our third postulate formula. Finally we get E equals to NHC by lambda. E equals to NHC by lambda. So the substitute of new value in equation third postulate, E equals to NHC by lambda. E equals to NHC by lambda. This is the third postulate of Planck's quantum theory. These are the three postulates which are present in Planck's quantum theory. The continuation concept this Planck's quantum theory is that is de Broglie's equation are dual nature of matter. De Broglie equation are dual nature of matter. So the de Broglie equation is an equation used to describe the wave properties of a matter, specifically the wave nature of the electron. So the formula of de Broglie equation is lambda equals to h by mv. Lambda equals to h by mv, where lambda is wavelength, h is Planck's constant, m is mass of the particle, v is the velocity of the particle. Okay, these are the de Broglie equation. Lambda equals to h by mv. So here de Broglie confirmed that the matter is in movement. The matter is in movement manner, which exhibits wave nature and also particle nature. Wave nature and also particle nature. So see this diagram. In this diagram there is a these two are the points. In between these 2 points, okay, one way is straight possibility. That straight possibility is the particle character. One more possibility is wave possibility. That is the wave manner. Okay, see the small derivation present in de Broglie's equation. In this de Broglie's wave equation derivation, we take two formulas. Okay, in these two formulas, first we consider according to Einstein mass energy relation. Einstein mass energy relation, that is E equals to mc square. Next we take Planck's quantum theory equation, that is E equals to h nu. We already know the new value hc by lambda. In these two considerations, E is a common letter. E is common letter. Energy term is common letter. So hc by mc square equals to hc by lambda. Finally we get lambda equals to h by mc. Here c is the speed of light. C is speed of light. The speed of light explain only light manner, light packets. Okay, but generally there is a energy packets. In that energy packets, we replace this speed of light c term with v, velocity of the matter. That velocity of the matter explains that both energy packet character and light packet character. So we get lambda equals to h by mv. Okay, where mv is nothing but momentum, mass of the matter and velocity of the matter. According to classical physics, mass of the matter and velocity of the matter is equals to momentum of the matter. Momentum of the matter. So finally we get the formula lambda equals to h by p. Lambda equals to h by p. That is the de Broglie's wave equation. Okay, de Broglie's confirmed these matter is in movement manner. That matter exhibits wave character and also particle character. Wave character means in between two poles, the movement takes place in two ways. That first way is in straight way. That straight way possibility is particle nature. Another way is wave nature. That is the wave character. Okay, so whatever it is, material is in movement manner. That material exhibits dual character, that is particle character and also wave character. Okay, de Broglie in the year 1923 proposed whatever the matter is in movement which exhibits particle character and wave character. Finally, the de Broglie's equation lambda equals to h by p term explains the matter having wave character and also particle character. Wave character and also particle character. Okay, so in lambda equals to h by p, lambda is the wavelength term. Wavelength term explains wave nature of the matter, and p term explain, okay, p term is explained particle character, that is the movement of the matter, that is particle character. P explains particle nature, lambda explains wave nature. Okay, once I repeated, listen. First, Planck's quantum theory. In that Planck's quantum theory, first we take A and B are the two persons. A person use continuous pumping of water, B person use a small stones. A is James Clerk Maxwell, B is Max Planck. James Clerk Maxwell confirmed that the matter exhibits continuous manner, that is absorption and emission is in continuous manner. Max Planck confirmed that absorption and emission process is in discontinuous manner. So, Max Planck in the year 1901 proposed Planck's quantum theory. He was awarded Nobel Prize in Physics in 1918. There are three postulates in Planck's quantum theory. The first postulate, energy is not emitted or absorbed continuously. Energy is not emitted or absorbed continuously. It is emitted or absorbed in the form of wave packets or quanta. Wave packets are quanta. Light packets is nothing but photon. Okay, in case of light, the quantum of energy is called photon. Okay, in a second postulate, the amount of energy associated with quantum of radiation is directly proportional to the frequency of radiation. E equals to h nu. E is proportional to nu. There is a proportional symbol. E equals to h nu, where h is Planck's constant. The Planck's constant value is in x case and Joule case value. Next one, third postulate, a body can emit or absorb energy only in terms of integral multiple of quantum of photon. So E equals to nh nu, where nu is nothing but c by lambda. Substitute that nu value, E equals to nhc by lambda. This is the Planck's quantum theory. Next, de Broglie's equation are dual nature of matter. Whatever it is, the material is in movement manner, which exhibits particle nature and also wave nature. Okay, according to that, there is a small derivation. In that small derivation, we consider two formulas. One is Einstein mass energy relation, E equals to mc square. Another one is Planck's quantum theory, E equals to hc by lambda. In these two equations, E is common. So we equal these two formulas. We get mc square equals to hc by lambda, where c cancel term, we get lambda equals to h by mc. In this, c is the speed of light. Speed of light explain only light packets. So the c term is replaced with velocity, that is velocity of the matter. We get lambda equals to h by mv. Okay, finally, according to classical physics, mass of the matter and velocity of the matter, mass of the matter and velocity of the matter is equals to momentum of the matter. So momentum of the matter is p. Finally, the de Broglie's formula is lambda equals to h by p. In this lambda equals to h by p equation, lambda explains wave nature, that is wavelength term. P explains that particle nature, that is the moment term. Okay, thank you students. Thank you for listening. This is our first concept, Planck's quantum theory and dual nature of matter. Thank you.